Okay, let's look at another example of light balancing. And we're going to use once again the longest task time rule. In this project, we have 10 tasks. And we see the task time in minutes over here in second column. And in the last column, we have the information on the preceding tasks. In addition, we know that the working hour per day is 12 hours, and we would like to make 90 units per day. Based on this, we're going to calculate the cycle time, the minimum number of workstations, efficiencies. Of course, we're going to complete task assignment based on the longest task time rule as well. In applying longest task time rule, there's no need for tasks to be completed in order. It's not like you have to finish A before you finish B. And you can assign non-adjacent tasks to the same person. A good example could be, say, a receptionist at a dentist office. She is responsible for patient checking in, checking out, payment, scheduling the next appointment, and so on and so forth. Those tasks can be completed by the same person. Next, let me switch to my Excel to answer all those questions. And first of all, let's get some of the basic information. Number of working hours per day, 12. Number of units per day, 90. And I copy the table from PowerPoint over here. In total, 10 tasks. First thing we would like to do is to find out about the total task time. To do that, it's very easy. We use sum function in Excel, and in total, it takes 36 minutes to complete all those 10 tasks. Next, let's calculate cycle time. We know that there are 12 working hours a day. 1 hour is 60 minutes. And we would like to make 90 units per day. That is to say, we have to make 1 unit every 8 minutes. And this is our cycle time, 8 minutes. Next, let's find out about the minimum number of workstations needed, capital N. Here's what we're going to do. N is equal to total task time 36 divided by 8. But keep in mind, number of workstations has to be integer. In our case, 36 divided by 8, that would be a decimal. So we're going to round it. Keep 0 decimal place. If you do so, it will always round up. Return. And we're going to need at least 5 workstations to ensure a cycle time of 8 minutes. Now let's calculate efficiency E. It's going to be equal to total task time divided by cycle time times the minimum number of workstations. Essentially, what this means is, out of the 40 minutes, the real working time is only 36 minutes. As a result, the efficiency is 36 divided by 40, which is 90%. Now let's look at the most complicated part of this problem, task assignment. And in this table, we have the original information. On the right-hand side, this is my task assignment table. Let's look at station 1 first. What are the eligible tasks? Let's take a look. A, B, C, all those three tasks have no immediate predecessor. What does it mean? It means we can begin the whole thing with either A or B or C. But we can only assign one task at a time. Which one goes first? And here's where the longest task time rule comes into play. A takes 3 minutes, B takes 3, C takes 4, so we're going to pick C. That would be the assigned task. How long does it take? Well, 4 minutes. Cumulative time, because that's the first one, cumulative time will be 4 minutes as well. Idle time, because every workstation gets 8 minutes, idle time will be equal to A minus 4, which is also 4 minutes of time. Workstation 1 has 4 minutes idle time. That means we can assign more tasks to workstation 1. What are the eligible tasks at this moment? The eligible tasks in this case will be A and B. C is already assigned to workstation 1. You may ask, what about all the other tasks? Say D, E, F, all the way to J. Well, those tasks cannot be assigned to station 1 because, for example, D has to wait until task A is completed. But at this moment, A is not assigned or completed. So at this moment, the only tasks that are eligible are A and B. Well, between A and B, let's take a look. Each of them takes 3 minutes. In this case, it makes no difference to assign A or B. But let's go with A. And if you put down B over here, that's also correct. And A takes 3 minutes. The cumulative time will be 4 plus 3, 7 minutes, because both tasks C and A are assigned to workstation 1. A and B combined take 7 minutes. How much idle time left? Keep in mind, 8 minutes available, 7 minutes are taken, so idle time will be only 1 minute. After that, well, we can no longer assign any other task to station 1 because it has only 1 minute left. Now, let's switch to workstation 2. Okay, what are the eligible tasks? First of all, B, of course, is still eligible. And who else? Because task A is assigned, task D becomes eligible. If you take a look over here, as long as A is completed, D becomes eligible. And between B and D, which tasks are we going to assign to workstation 2? B takes 3 minutes, D takes 3 minutes. Well, once again, it doesn't really matter you assign B or D. And then, for the sake of convenience, let's assign B. Over here, B takes 3 minutes, and the cumulative time will also be 3 minutes because this is a brand new workstation, workstation number 2. Idle time will be 8 minus 3, 5 minutes. Okay, still plenty of room for another task at workstation 2. What are the eligible tasks over here? A, B, C are assigned. As a result, let's take a look. D is the only one eligible at this moment. Because, say, if you want to assign task E, well, it cannot be done because you have to wait until task D is completed. So D is the only task eligible. As a result, we're going to assign D to workstation 2, which takes 3 minutes. Cumulative time will be 6 minutes because B and D are assigned to station 2. Idle time will be A minus 6 2 minutes. 2 minutes is not going to be enough for the next eligible task. So we are going to look at workstation 3. Which tasks are eligible? Let's take a look. A, B, C, D are assigned. After that, E is the only one eligible. So we're going to assign E to workstation 3. It takes 5 minutes cumulative time, 5 minutes idle time, A minus 5, which is 3 minutes. And after E is completed, we have room at station 3 for one more task. At this moment, A, B, C, D, E are completed. As a result, who are eligible? F, of course, is eligible. And G, in theory, is also eligible. But here's the dilemma. We have only 3 minutes left at workstation 3. F takes 2, but G takes 6 minutes. Even though both F and G are next in line, we cannot assign G to workstation 3 anyway because it takes way more than 3 minutes. As a result, the only task eligible over here will be F. So we're going to assign F to station 3. F takes 2 minutes. Cumulative time will be 5 plus 2, 7 minutes. Idle time will be A minus 7, 1 minute. Alright, that's about it on workstation 3. Let's look at workstation 4. Right now, A, B, C, D, E, F are all assigned. As a result, task G is eligible. So is task H. Between G and H, G takes longer, 6 minutes. Once again, we apply longest task time rule over here. Assign task G to workstation 4. G takes 6 minutes. Cumulative time 6 minutes. Idle time A minus 6, 2 minutes. Only 2 minutes left at workstation 4. Not much we can do at this moment. Now let's switch to workstation 5. A, B, C, D, E, F, G are assigned. As a result, H is eligible. So is workstation I. Well, H takes 4, I takes 4 minutes. So it doesn't really matter which one you're going to assign over here. Let's go with H. Alright, it takes 4 minutes. Cumulative time 4 minutes. Idle time A minus 4 is also 4 minutes. Workstation 5 again because it has enough time. Now there's only one choice. Task I. Only task that is eligible. So we're going to assign task I to workstation 5. It takes 4 minutes. Cumulative time will be 4 plus 4, 8 minutes. Idle time, of course, nothing left at workstation 5. Alright, here's the tricky or interesting part. And we have one more task left, which is task J. And, well, we're going to assign task J to somebody, right? And J takes 2 minutes. Let's take a look at all the previous workstations. Station 1 has only 1 minute left. No, it's not going to work. Station 2 has 2 minutes left. Okay, it's good enough. Station 3 has only 1 minute left. Not good. Station 4 has 2 minutes left. That's also okay. Station 5 is 100% busy already. No idle time whatsoever. So over here, you can either choose Station 2 or Station 4. Let's go with Station 2. Alright. So the cumulative time will be, okay, for workstation 2, 6 plus 2, 8 minutes. In the end, there will be no idle time left at workstation 2. So what do we see? Workstation 1 will get task A and C. Workstation 2 will be getting task B, D, J. Station 3 gets E and F. Station 4 gets G only, and Station 5 gets H and I. Workstation 2 over here is similar to what I mentioned earlier, the receptionist at the dentist office. She's responsible for checking in, sort of like task A, but she is also responsible for checking out the payment, scheduling next appointment. Those are similar to our task J over here.